Hello students, following question is a 2-mark question from topic of design of members that are subjected to shear, and it is again a question from design of RCC structures. Here some parameters regarding shear strength properties of concrete is given, that it is M20 grade concrete which is having value of tau C for tension reinforcement as 1.43% as 0.706 Newton mm square, and tau C max of this concrete is 2.8 Newton per mm square, and it is simply asked that what is the spacing of two-legged 8-5 bars that is required as per recommendations of standard code, that is IS 456-2000. Now let us say that total shear force that is acting is Vu, and it is given as 250 kilonewton. Out of this 250 kilonewton, some of the force will be resisted by virtue of the shear resistance property of concrete, and that resistance of concrete is given by this coefficient. In fact, I will be writing it as TBD as tau C into BD. So this much of shear force that will be itself resisted by concrete, and for remaining shear force we need to provide some additional reinforcement. So if this is marked as TU, then TU minus TBD will be the design shear force, design for which you need to design the reinforcement. So first of all, let's calculate that what is the value of tau V, that is the maximum shear stress that is induced in cross section. So it comes out as 250 into 10 to the power 3. This is to convert kilonewton to Newton divided by both dimensions in mm. So it comes out as 2.22 Newton per mm square. Now in this case, tau V, that is actual shear stress, is less than maximum permissible shear stress, which is given as 2.8 Newton per mm square. Hence we can calculate that what is the spacing required. Had this condition been not met, then we need to revise the cross section. So if we talk about shear force for which stirrups shall be designed, that is TUS is TV minus tau CBD. TV is total shear force, that is 250 into 10 to the power 3 minus tau C, that is 0.706, which concrete itself will be resisting, into 250 into 450. So this is the design shear force for which we need to design the reinforcement. So it comes out as 170.575 kilonewton. Now as per recommendations of IS 456-2000, the spacing of reinforcement is given by 0.87 Fy ASV, which is the force that is being resisted by the two-legged 8 stirrups into D upon TVS. Not two-legged, it may be 4-legged, 5-legged. Accordingly, area of steel will change into depth of the section divided by that force for which we have to design the shear reinforcement. Simply by substituting the values, Fy as 415, ASV is 100.53, which comes out as 2 into pi by 4 into 8 square, into depth of the section, which is given as 450, divided by tau Vs, that is 170.575 into 10 to the power 3. So answer comes out as 95 mm center to center, and C represents the best and closest choice for that. Thank you.